The rate often depends on the concentration of one or more of the reactant molecules, and that concentration is raised to a power n, and we call that the order. It's usually an integer value, and it helps us to determine how the rate depends on that reactant concentration. Typically, we're going to see values of 0, 1, or 2, although it can be other values as well. So if we have a reaction of a decomposition reaction where A breaks apart into products, our rate law, because it depends on the reactants raised to a power, our rate law is going to be the rate equals K, which is our rate constant. So it's a proportionality constant of the concentration of A raised to that order. So this is our overall general reaction rate law. Let's look at an example using our rate law for a reaction of nitrogen monoxide with ozone. Our overall rate law is the constant times the concentration of nitrogen monoxide times the concentration of ozone. And there's no exponent written, so our exponent would be 1 for each of these concentrations. So let us calculate the rate constant. So we know that the rate equals our constant times the concentrations of each of our reactants. And we're going to rearrange it and solve for K. So we're going to divide both sides by our nitrogen monoxide concentration and ozone. And so K is equal to the rate divided by our concentrations. So we can plug these numbers in. We've got the rate with units of molarity per second divided by our concentration of nitrogen monoxide and our concentration of ozone. So our constant is 2.20 times 10 to the 7th. And if we look at our units, so one molarity is going to cancel, but the other will not. And so our seconds is going to be 1 over molarity seconds, or you might see it written as molarity to the -1, seconds to the -1. And so that would be our units for our rate constant. Here's a practice for you to try. Determine the rate of the decomposition of acetaldehyde. Pause the video to determine your answer. Our rate law is equal to our rate constant times the concentration for acetaldehyde to the second order, so it's squared. And so we have to plug in our numbers. We're given the rate constant. And we have the concentration of our acetaldehyde. And we do need to remember to square it. And so our rate is equal to 2.06 times 10 to the -11th molarity per second. If we look at our units, so our we're going to end up with molarity squared from the concentration. That'll cancel with 1 molarity. And so we end up with molarity over seconds as our rate, which is what we would expect because it's a quantity, molarity over time.